Software development relies on automated, Git-based version control to track code changes and prevent errors. Industrial automation is trying to catch up, moving away from saving endless folders of manual backups. Standard Git is built to track and merge changes specifically within text-based code, like Python or C++. But if you work with Allen Bradley hardware, your industry standard for storing PLC projects is the .acd file. An ACD file is a compiled, proprietary binary file. The internal ladder logic, the tags, and the routines are not stored as readable text. When you feed a binary file into a standard Git repository, the system can't read the logic. It only detects that the total file size or the checksum is different. This flowchart shows exactly where standard Git hits a wall in an operational technology environment. The commit process bounces right off the locked binary file, generating a generic error instead of a detailed history. Knowing that a file changed is useless for troubleshooting on the floor. To fix a problem, engineers need to know exactly how the logic was altered. When a machine suddenly halts mid-swing on the factory floor, it is often due to an undocumented logic modification. The standard response is to pull the local running file and manually compare it to the last known good backup. This forces an engineer to open Studio 5000 and manually audit the logic, scrolling rung by rung, hunting for the specific instruction that caused the fault. Every minute spent hunting for a change is a minute of lost production. Successfully translating a proprietary binary file into readable, trackable logic requires a choice. You either spend engineering time or you spend software money. The market offers distinct tiers of solutions. The one you choose depends on how much visual clarity your team needs. There are three main paths: free command line workarounds, web-based visualizer tools, and enterprise industrial DevOps platforms. Choosing the wrong tier for your specific setup often leads to a mismatch between your budget and the actual speed of your engineering team. The first tier is the free, do-it-yourself command line workflow. The core mechanism for this approach is Rockwell Automation's free custom VCS tools. To get started, you have to clone the repository from GitHub and build the tools into an executable format using a command line interface. Once installed, the primary process involves taking your binary ACD file and converting it into an exported L5X file. Because L5X files are large, the tool performs an explosion. It breaks that giant XML file down into smaller text components organized into separate folders. This diagram outlines how extracted files integrate into a Git repository. Trace the center path. The extraction moves from the L5X conversion down to local Git folders. Then, standard Git commands merge the text files and push them to a remote repository. The trade-off here is the output. Your records of what changed are presented as raw XML text. This tier saves your financial capital, but it demands a technical setup barrier and forces engineers to read text files to understand logic updates. The second tier is the web-based visualizer. Platforms like PLC Company are the prime example of this mid-market approach. Instead of using the command line, an engineer manually uploads their ACD or L5X file directly to a secure web portal. The portal parses the file and generates a color-coded view of the ladder logic, showing added, removed, and modified instructions side by side. This enables cross-team logic reviews without the cost of additional software seats for every user. Looking at this comparison matrix, the DIY workflow gives you low cost, but requires high setup effort and yields an XML output. The web-based tier requires low setup effort and provides visual output, but it comes at a medium cost. The workflow trade-off here is friction. Relying entirely on manual file uploads breaks a seamless native Git workflow. Financially, you are replacing upfront engineering effort with a recurring SaaS subscription of roughly $300 a month. The web-based tier is an effective tactical fix for visualization, but the manual steps mean it falls short of a fully automated CI/CD pipeline. The final tier is enterprise industrial DevOps platforms. Copia Automation is a common standard for enterprise-grade PLC version control in this space. Rather than pushing files to a separate web portal, this software natively renders ladder logic directly inside the Git environment. This solves a threat for large operations: code overwrites. When multiple programmers edit the same file simultaneously, standard tools will often blindly overwrite one engineer's work. To prevent this, enterprise platforms use concurrent merging. The software analyzes the structural logic conflicts between two different developers and resolves them automatically. Updating our matrix, the enterprise tier requires the highest investment and a high setup effort, but it provides visual outputs and enables concurrent merging. The trade-off is significant. You pay a higher financial cost, and your team has to undergo an organizational shift in their daily engineering practices. For multi-developer environments, these platforms prevent the logic overwrites that cause extended downtime. Removing friction in PLC version control scales linearly with your financial investment. We can map these tools onto a decision framework to properly align them with specific operational profiles. The first profile is the solo engineer, or a budget-constrained team. They have the time to learn a new workflow, but they lack the budget for monthly software subscriptions. The Rockwell Custom VCS tools drop into the high-effort, low-visual insight quadrant for this user. The second profile is the maintenance team and the compliance officer. They need visual auditability on the plant floor to troubleshoot faults, but it is not cost-effective to buy Studio 5000 software licenses for every user. The web-based visualizer belongs in the low-effort, high-visual insight quadrant to serve these compliance-focused teams. The final profile is the multi-developer enterprise team. When dozens of engineers are pushing logic changes, raw XML overwrites become a risk to production stability. Enterprise Industrial DevOps expands the high-effort, high-visual insight quadrant by adding concurrent merging, specifically built to protect large teams. Matching your operational scale to your Git integration tool secures your automation uptime and stabilizes your development pipeline.